10.3 Simple linear regressions. These are the learning outcomes for this lesson. Simple linear regressions. The linear regression equation is the equation that defines the linear relationship between the two variables. The equation of this straight line can be determined using the least square method. The linear regression line of y on x is given by y equal to a plus bx, where b is given by this formula and a is by this formula. A and b are called the regression coefficients. B is the gradient of the regression line. A is the y-intercepts of the line. In general, this is the interpretation for the value of b and a. Again, you must remember this. B, the value of b, means that as x variable increased by 1 unit, y variable increased by b units. A equal to the value of a means that when x variable is 0, y variable is equal to value of a. Example 1. For the data given below, plot a scatter diagram. So plot a scatter diagram when x equal to 6, y equal to 2 is here, and so on. So this is the scatter diagram for the data. As you can see, there is an obvious line on the data. When x increase, y also increase. B. Determine the linear regression equation by using the least square methods. So linear regression equation, so we are looking for y equal to a plus bx. Total of x equal to 105. Total of y equal to 67. Total of x squared is 1185. Total of xy is 788, and n equal to 10. B is given by the formula, and substitute the value, we get 1.0242. And a is given by this formula, and substitute the value, we get negative 4.0541. So substitute into the equation y, we get y equal to negative 4.0541 plus 1.0242x. Example 2. The following table shows the results of an experiment where 8 similar plots of land were given different amount of water in ml, and the resulting yield of corn in tons per acre was recorded for each plot. Find the equation of regression line of y on x. So regression line is given by equation y equal to a plus bx. So we have n equal to 8 similar plots of land. Then total of x equals 680, sum of all x. Total of y equal to 49.97, sum of all y's. Total of x squared equal to 66,200. Total of x times y is 4,507.8. And b is given by this formula. Substitute, we get 0.013 for b. And a is given by this formula. Substitute, we get a equal to 5.1413. And this gives us the equation y equal to 5.1413 plus 0.013x. This is the regression line of y on x. A, interpret the regression coefficients. So we have a and b. B equal to 0.013 means that as every ml of water add, the yield of corn increased by 0.013 tons per acre. And a equal to 5.1413 means that without any water add, 5.1413 tons per acre will be produced. C. What would you expect the yield to be for a plot where 70 ml of water was added? 70 ml means x equal to 70. The regression line is y equal to 5.1413 plus 0.013x. So now x equal to 70. Substitute 70 into equation, we get y equal to 6.0513. So the yield is 6.0513 tons of corn per acre. Example 3. A college offers information technology courses. The cost of managing the course depends on the number of registered students. The table below shows the relationship between the number of registered students and the management cost. So A, plot the data on a scatter diagram. So first we have number of students 16 means X equal to 16, cost is 2.7 thousand ringgit, and so on. So this is the scatter diagram for the data. B, find the linear regression equation for cost on the number of students and draw the regression line y on x on the scatter diagram in A. Regression line is y equal to a plus bx, where n equal to 10 students, total x is 403, total y equal to 50, total x square is 22,413, total x times y is 2567.2, and b is given by this formula and a is given by this formula, and substitute we get b equal to 0.0895, and substitute value into a, we get a equal to 1.3932. Then the linear regression equation is y equal to 1.3932 plus 0.0895x. So draw a straight line connecting all the dots if possible. If not, the number of dots above should be equal to number of dots below line. C, interpret the regression coefficients. B equal to 0.0895 means that as the number of students increase by 1%, the cost will increase by Rm 89 ringgit and 50 cents. A equal to 1.3932 means that when there is no student registered, the cost is Rm 1,393 ringgit with 20 cents. D, estimate the management cost if there is 90 registered students. Comment on your results. So 90 registered student means x equal to 90, and we have the regression line y equal to 1.3932 plus 0.0895x. So now x equal to 90. This will give us y equal to 9.4482. So the management cost is Rm 9,448 ringgit and 20 cents. The estimate management cost for 90 registered students is not reliable since x equal to 90 is outside the range of given data. Okay, as we can see, the lowest value for data is 8 and highest is 77. So 90 is outside the range of the data. Example 4. The following data shows the units of output produced with the total cost spent for a factory. A with the units of output as independent variables and the total cost as dependent variables. Find a straight line which best fit the data by using the method of least squares. So the least square method gives us equation for y equal to a plus bx, where n equal to 8, total of x is 260, total of y is 420, total of x square equal to 9,750, total xy is 14,900. b equal to this formula and a equal to this formula. Substitute, we get b equal to 0.9615, and substitute a equal to 21.2513, and this gives us the linear regression equation is y equal to 21.2513 plus 0.9615x. So this is the straight line that best fit the data. B, estimate the cost at the output level of 26,000 units. So 26,000 units means x equal to 26 as the data is already in thousand. So x equal to 26. And we have the equation of straight line is y equal to 21.2513 plus 0.9615x, where x is 26, and this gives us y equal to 46,250 and 30. So the estimate cost is Rm 46,250 ringgit 30 cent. The estimation is reliable as 26,000 units is within the interval of output level in the given data. The estimation is reliable as the data is from 10,000 units to 50,000 units. So 26,000 is still in the interval of output level. Second, 55,000 units. So x equal to 55, and the equation gives us y equal to 74.1338. Means the estimate cost is Rm 7,430 ringgit with 38 cent. And this estimation is not reliable as 55,000 units is outside the interval of output level in the given data. So again, the interval of the given data is from 10,000 to 50,000 units only. So 55,000 is outside the interval, means it is not reliable. This is your exercise. Please submit the exercises at the end of lecture.